Hello there. I am just picking up where we left off with the final exam for probability, and that is page 76 in this textbook. So I'll slide on over and we'll start going over these answers. Or you can check your answers in the back of the book if you have the textbook to have the test. The answers are in the back. So page 76. The explanations are not in the back, so that's why I'm doing these videos to help you with those if you need them. Number 1 says the probability of 2 or more simple events happening is a compound event. You can generally think of simple and compound as opposites. Simple is the opposite of compound. Number 2, blank is the study of how likely it is for an event to occur, and that is probability. I'm capitalizing because it's the first word of the sentence, probability. Number 3, a blank is a way to show possible outcomes that resembles a branching tree. Well, no surprise that this is called a tree diagram, and we'll be looking at some of those in just a minute. Number 4, you flip a coin 15 times. The probability that on the 16th flip it will be heads is a or an blank. That is an independent event because the first 15 flips have nothing to do with the 16th. The 16th event is independent of the first 15. The probability that today is not Tuesday is the blank of the probability that today is Tuesday. Those are complements. Those are opposites. Complement is a word that's used often in math. And just while I'm thinking about it, if you compliment someone on their appearance, that's a different spelling. So the mathematical complement has ease. If you compliment someone, this letter would be an I. And that has nothing to do with anything other than general knowledge. Number 6, an event that depends on the result of a prior event is a dependent event. For example, if I draw a card out of the deck and I do not return that card to the deck, any future draws will be dependent on that first one. It's usually a problem that involves drawing something and not replacing it. Okay, let's take a look at problem number 1. And there are different ways to do some of these. I'm going to use the way that I think is simplest, but it doesn't mean that that's how you had to do it. If you got the right answer, it's correct. So it doesn't matter if we're doing them the same way. What matters is the answer. There are an apple, orange, and pear in a fruit basket. Marcus randomly selects one piece of fruit to eat each day. What is the probability that Marcus will choose an apple before choosing a pear? I used a tree diagram on this one because to me that's the easiest way to do it. So in this basket there is an apple, there is an orange, and there's a pear. And they tell me that in the problem. So let's suppose that the first day, these are the first day choices right here. And I think I'm going to try something here. Let's do apple, orange, and pear. So those are my first day choices. He could choose any one of those. So let's assume that on the first day he chose an apple. On the second day, there are two possible events that could occur. If he chose an apple on the first day, and I'm assuming he ate it, he didn't put it back in there, then on the second day, he could choose an orange or a pear, because those are the only two things left. And I'm going to put a box around those. Let me try to keep it all the same size and speed this up a little bit. So there's second day. Or he could have chosen the pear on the second day. Okay, if the first day was an orange, again, there are going to be two possibilities for the second day. And can you tell me what those would be? It could be the apple. So it would have been orange on the first day, apple on the second. Or if he did the orange on the first day, he could do the pear on the second. Okay, same situation here on the last choice. Let's suppose that he chose the pear on day 1. Then on day 2, he could have chosen the orange, or the apple. And then finally we need to look at day 3. So on day 3, let's follow this train of thought. Apple first day, orange the second day. So what would he have to choose on the third day? That would be the pear. So apple, orange, pear. Or he could do the apple, the pear, and then this would make the third day be the orange. And I know this can get very confusing very fast. So this is saying that on the first day he chose an apple. He could have done orange and pear or pear and orange on the next 2 days. Okay, on this one he chose the orange. Second day could have been an apple. So if he did the orange and the apple, then the third day would have to be the pear. So there's one possibility, orange, apple, pear. Or he could have done orange, pear, and the third day would have to be the apple. Okay. Orange, pear, apple. All right, the third possibility would be a pear the first day, an orange the second day, and so that would leave only the apple for the third day. Or if he did pear the first day, apple the second day, that would leave the orange for the last day. So all this diagram is doing is showing me the possibilities. It's showing me the different outcomes. And we're looking for the probability that Marcus will choose an apple before a pear. So let's follow this first scenario right there. Is the apple before the pear? Yes. The apple's first and the pear is third. So yes, this one has the apple before the pear. Okay, on the second one, we've got the apple and then the pear. So yes, the apple is before the pear. Rather than have to write that every time, just going to plop that right there. Okay, how about this next scenario? I'm looking at this one. Is the apple before the pear? We have orange, apple, and then pear. So yes, even in that scenario, the apple is before the pear. Okay, in this scenario, orange, pear, apple. In this case, the pear is before the apple, so no, that one is not one of my possibilities. Pear, orange, apple. Well, the apple is not before the pear in that one. Pear, apple, orange. The apple is not before the pear in that one. So of these 6 different possibilities, how many times was the apple before the pear? 3. And you've got your probability. But if you type that 3 fraction 6 into your calculator, you will get a reduced probability of 1/2. So you have a 50-50 chance of seeing this occur. The probability is 1/2 or 50%. And this is a tree diagram. And I should have gone ahead and filled in those choices. Okay, I'm going to stop this video. It's getting very long. So I'll see you in the next video, and we'll pick up right down here with problem number 2.